of Univac Environment Systems Private Limited for unitary and applied HVAC systems. He is a partner of Tropical Air Conditioning and Refrigeration, training HVACR professionals and representation of Ali for certification of HVAC equipment. Coming with an engineering background from IIT and around 5 decades of experience in HVAC industry, he is a regional lecturer, REL, ESHRE. Mr. Vikram is a presidential member of ESHRE and past president of ESHRE, Mumbai chapter and Rotary Club of Bombay Film City. He draws his experience as project manager, Voltas Limited, director at Gen Power Electric Private Limited, and executive VP of Utility Engineers India Private Limited. He is also a member Technology Task Force, Ministry of Housing and Urban Affairs, and Government of India. Today, Mr. Vikram will give us a brief view of thermal control in public buildings for low energy consumption. So delegates, let's welcome Mr. Vikram.
My presentation is going to be limited to more about buildings which take care of their thermal ingress, that means the heat coming from outside, by virtue of their construction. So they allow less heat to come in because of the way they are designed or the architecture has made them, and so on and so forth. And about control and about better management, you will hear more from the other speakers, so that we have a nice sequence of talk. So here is a public building or a utility. So public buildings are occupied by anybody and everybody. That is my definition of a public building. And these are usually larger spaces, and they may be used for a long period of time, shorter period of time, but certainly they are accessible and they should be comfortable. So here an example of a church, and I think it's in the Netherlands. So this church, because people aren't coming to pray in church, because I think man nowadays assumes that he's closer to God, but that's in a lighter note. So this church has been converted very nicely to a public library. So see how beautiful the library is. So a church is very tall, so it is naturally comfortable. Its walls are very thick, so it admits less heat into the building, and then the air conditioning load is substantially reduced. Here's an example of a museum in China. So you see, there's nothing much to look at this building. It doesn't look very beautiful, but it is built with very thick walls and very small slits for windows to admit light to the right places. So it's naturally comfortable inside, and the people who are going inside here are more interested in seeing the display of the museum. So this building also is comfortable with less requirement to cool it. Here's an example of a building. It looks let me put on a pointer so I can take you to the places which I want to highlight. So this building has been given a very large, quite modern art looking shade, like a big tent, you know. So it cuts down the solar radiation by the sun very substantially and adds an architectural feature to the building, and therefore it has got cooled by some process of architecture. Right? So the control has been done by that. So much of the daytime, from let's say 12 o'clock in the afternoon to 3 o'clock in the later afternoon, we get very good protection from solar radiation. Here is a building which is in the city which I live, Mumbai. This is the Mumbai International Terminal 2. It was designed by Skidmore, Owings and Merrill, which is a reputed, very old architectural firm in Chicago. So the beauty of this building is it admits natural light very easily. It is very open in its spaces. Because of its design outside, it has got very good natural shading. So solar gain doesn't come inside the building, although it looks very open. And its ventilation systems are such that air is thrown, I'll be talking about this later, at a low level. We don't cool the whole space above. We cool only the level up to, let's say, 8 or 10 feet above the ground, because that's where the people are. So this is one of the methods of controlling the need of air conditioning, by letting the air come at a lower level, displacement ventilation, instead of doing whole space cooling, right? Here's another building. This is in Brooklyn in New York. This is a building which seems to have converted its roof into a garden, but actually it's a roof, a cool roof. So the garden affords very good protection from heat to come in. It also adds some natural beauty. It also gives, as I said earlier, protection, and it gives the public a very grand appearance when they come in to watch this building. And this is a botanical garden, so surrounding it is lovely trees and so on. So it's also well shaded by all these trees. So shading is one big factor. This is a building, this is a library in Seattle, in Washington. So the Seattle city, it's on the coast in the northern part of United States. It has quite mild climate. It is not very hot it gets cool, but it doesn't get very cold. And so they enjoy the sun, especially in the winter. And so while this building appears to become very hot because it's got so much of glass, because of its orientation and the angles of the glass, it doesn't get hot at all. So it's beautifully designed. See this angle of the shade. It's just designed by an architect who's quite a famous architect. His name is over here. I'll share this presentation with the organizer. So all of you, if you want, you can look at these pictures later to get an idea that public buildings are sometimes designed, most often actually, I will say traditionally, to admit less heat. Here's the Museum of African History, African American History in Washington DC. So it is supposed to represent the crown of an African king, you know. So that's what it's supposed to look like. And so while it has all these reflective surfaces which make it very shiny, actually they are reflecting away the sun. And there's a nice pool around it, so evaporation takes place with naturally cooling. It admits light, but in a very restricted way. So you can see light, shade, evaporative cooling are good ways to control the ingress of heat to a public building. This is a concept which we are doing also in Mumbai. So Radeshwari and Gopal will know that we have lots of flyovers in Mumbai and in Lower Parel and some other places. The Mumbai city is creating all these beautiful public spaces below the flyovers, which were otherwise looking very ugly, but now they look very beautiful. There are gardens, there are places for children to play. There are little, some people come over there and give some talks and so on and so forth. You can see how nicely we can do an open space. This is not cooled by mechanical means. It's an open space, but it is a public space and it is comfortable, right? This is the Baha'i temple in Delhi. It was built not very long ago. It's modeled on the shape of a lotus. So it's sometimes called the Lotus Temple. Because of its shape, it allows heat to go away and escape from the outside. It's surrounded by water and fountains, so it remains very comfortable in summer, and in winter it doesn't get very cold. And so you can see the interior, how beautiful it is. So this is another public building which is well ventilated, has lots of light coming in, has lots of ventilation outside. This is the General Post Office in Bombay. It may be more than 100 years old. I don't know how old it is, but it's very old. It is getting repaired now. I saw it a few days ago because it's so old. But yet it is functional. It has very large 2-level spaces in the main hall. And as you can see, it's very well ventilated, very well lit. It's cool and comfortable. Obviously, it must be because so many people are working here. And some places are air-conditioned above. No doubt about that. This is the Victoria Terminus, Chhatrapati Shivaji Terminus in Mumbai. It is also a very old building, but now the government of India is modernizing this terminal, one in Delhi, one in Ahmedabad and one somewhere else, and adding an annex, which is a modern one, which will be air conditioned and everything else, but it will not look very different from the construction of this building. So they will blend it nicely. But this Victoria Terminus is naturally cool, naturally ventilated. It has fans above, as you can see. So now we do a little bit of technical talk. So Mumbai today is at 32 degrees centigrade and 28 degrees centigrade wet bulb. So it's a 75% relative humidity. This is the month of October. So it is quite humid in the psychrometric chart. We have got very high humidity today, not very high temperature. So it is okay in temperature, but it is uncomfortable. So we must have to do air conditioning or somehow remove the humidity to feel more comfortable. So this is the problem. Either it's hot in India or it is humid in most of the places. And therefore, because both these challenges are there, we have to be able to do one thing, which is we can adapt to comfort, right? So ASHRAE has a standard 50, which talks about adapting yourself to comfort. There is no need to get very cold in summer. There is no need to heat up the place too much in winter. So our human body recognizes temperature. It recognizes radiant heat from surfaces. If you make your public building with too much of glass, they will radiate a huge amount of heat inside. No matter how much air conditioning you do, the guy near the glass is going to feel uncomfortable. Air motion, we must have good air motion. You can increase air motion with fans if the system doesn't have enough air distribution naturally. ASHRAE in 2020 came out with a standard to battle COVID, where we said you can maintain temperature between 24 and 30. Depending if you are in a dry place, then you maintain higher temperature. If you are in a humid place, you maintain lower temperature. And so this is a way to adapt and reduce energy in in public places and our home. So here is a program called Energy Plus. It's a simulation program. So my good friend Subbu, who is a panelist here, he does a lot of work in simulation. So simulation allows us to simulate, to model how the building will behave. And using those tools of simulation, we can very well predict, or we can design the control systems and the building management systems of how shall we operate this building intelligently and with a good building management system. So public buildings as well as other commercial buildings will do very well to have the modeling and simulation done well in advance, so we know how we can take care of them because of changes in occupancy, lighting, temperature, and so many things which are all mentioned here. Because this is a short seminar, I'm not going to talk too much in detail about that. And here you can do the imaging of a building. You can have an infrared thermometer and you can create a thermal pattern, and you can see where all the heat is coming more. If you find that walls are emitting too much of heat, it's good to spend money and do insulation, and you can reduce the heat from going inside. If glasses seem to be getting too hot, we must do shading over there. So this is a good tool to be able to plan how the building will behave even before it's occupied. By doing some thermal imaging at 2 o'clock, 4 o'clock in the afternoon, you can do such a thing. We can also study the climate. Climate data is available from the Indian Society of Heating, Refrigerating, Air Conditioning Engineers design book on weather data. So you can see pictorially how the different times of the year, the heat ingress, the variation on 24 hours, all these things you can study, and you can plan your design for public buildings as well as other buildings. Also, you can assess how do we have the peaks on a hot summer's day. Remember, challenging and trying to take care of the peak is one of the most difficult tasks in managing the heat ingress or the behavior of a building. So all these studies are very good to do and be able to control the public building. This is a very old, I will say it's not a public building, but it's a palace. But the palaces of old days allowed many of the, the citizens or whoever they are to visit the palace on some days. So this palace is cooled by evaporative cooling. There's a large reservoir at a great height. The water comes and it comes out of these little jets as a fountain, and it evaporatively cools the whole place. So while it is 43 degrees in Rajasthan, Bharatpur, inside or around it, it is as cool as 22.5, which is the wet bulb temperature. Because of the nature of the spray, we come very close to the wet bulb temperature. So it is naturally cool. The Taj Mahal is cooled in another way. This is also a public building if you think about it, because it's full of public most time of the year. It is cooled because of the river Yamuna. It acts as a thermal, shall we say, ingress in the winter months to cool the whole base of the Taj Mahal, which is very big. It goes deep into the ground and it acts as a thermal storage of coolness, which right through the summer is radiated and people feel comfortable, apart from other ways in which the Taj is cooled because of ventilation and because of the way its grills are designed to admit air at a high velocity. This is an institute. This is where I studied many years ago. So long back, it had in the 60s it was built and it was commissioned, and there was a 1,000-ton district cooling system which is still in existence, but it's modified. So there was what is called a spray pond outside the library, and this spray pond acted as the cooling tower. So the spray, of course, the cooling tower efficiency is less with the spray pond, but it produced a very good environment around the library. And because there was district cooling, the load was distributed, and because of the huge variation in load, you could afford to do 1,000 tons where otherwise 3,000 tons might have been required or more. And similarly, we have so many examples in India. So let's talk about India as a country. We have at least 5 different climate zones, hot and dry, warm and humid along the coast, composite weather, cool weather. But because of all this, there are some things to note. India is the 7th largest country. There are bigger countries, Russia, Canada, China, the US, Brazil, Australia. But we are the 3rd largest producer of electricity. So you can see, although we are a very large population, our per capita use of electricity may be small, but we are producing huge amount of electricity, a large amount of which goes into cooling. How much electricity did we generate in 2020, 21, 22? 1600 terawatt hours. So energy is watts into hours. 1600 terawatt hours. A terawatt is 1 quadrillion of a watt. 1 followed by 12 zeros. It's a very big number and it's a huge amount of power. This is growing 10-15% every year. Out of that, cooling was 135 terawatt hours 4 years ago. In 2038, 20 years or maybe 18 years from now, how much is this? 16 years from now, we will need 4 times or 5 times that energy. So you can see there is a big need to do something about it for public buildings. Let me tell you one thing about public buildings or commercial buildings. They form only 30% of the air conditioning installed, 70% is residential. But residential works for 4, 5, 6 hours a day. Commercial and public buildings work for 10 hours a day. So if you multiply hours into cooling energy, you will find that the public buildings might be consuming more energy, or the commercial buildings all put together much more energy than the residential buildings. Even though residential building tons might be higher, the time of working is very less. So that's something to know. So we can use many other interventions. I've taken this from the India Cooling Action Plan released by the Ministry of Environment. You must all read it. So one of the ways is indirect, direct evaporative cooling. I won't talk too much about it, but you read the slide. It is you first dry the air without exposing it to moisture, and then you cool it, and you can get very low temperatures, lower than the wet bulb. That's a beautiful thing. Naturally cooling, a place like Pune, you can get 21 degrees centigrade leaving, whereas the wet bulb might be higher, 23 or 24. Structure cooling system. This is also being used today, where we are able to cool structures by circulating water through the structures, or even by keeping the walls wet, or by having some other way of cooling the structure. Even shading is a way of structure cooling, actually, or evaporating water around it. Radiant cooling is another way, and which is getting very popular. Here you can see, this is you cool the roof, or you cool the floor, or you cool the walls by pipes which are buried in the ceiling or the floor, and cool water is circulated. So radiation removes the body heat. There's no need of any fan or anything like that. It's a wonderful way of cooling, and the cooling is restricted to where the person is. And this is increasingly being used in public buildings or even in private buildings. Infosys, of course, it's not a public space, but they are using it extensively in Mysore and Hyderabad, other places, to reduce their loads by as much as 35%. I talked about displacement ventilation. So that Mumbai airport, you cool from a lower level. You will see boxes inside the airport which are cooling. Most airports now in India, we are cooling at a lower level rather than cooling air right from the top. So this is a good way to save energy in public spaces also. This is a little more technical. This is a recovery of heat of fresh air by the cool air which passes out of the air conditioner. You can recover some of that heat through a heat pipe, and you can save 15-20% of the hot outside air coming into your air handling unit. You can do underfloor air conditioning, which is not very different from displacement cooling. This also allows us better control of spaces for cooling. Or you can have chill beams, which is a nice new, more modern way of cooling quietly, removing all the sensible heat, and very good for large spaces. And if there is more humidity load, we can remove that with a separate duct system. So these are various ways. The adsorption ADSOR chiller is made by Briar. Debashish is from a sister company, but this is a wonderful. Debashish is going to speak later today. It's a wonderful device which uses desiccant and vapor pressure difference to cool water down to 7 degrees, same temperature as a chiller, but it doesn't require electrical energy. It requires warm water at 36 degrees centigrade, not hot, warm water. You can easily get this warm water as waste heat, or using solar thermal, not solar electric, solar thermal, to get warm water. And they are making machines up to 300-400 tons. In America, they make even bigger ones. Of course, this is a good future way of cooling public buildings, adsorption. And I think it's a wonderful thing to progress. It may have a larger capital cost, but it doesn't have any running cost if you use solar to give it its energy. So this is the India Habitat Center at Delhi. It's a beautiful building. There's an architect, he's not there now, Joseph Allenstein. He later partnered with Mr. B.V. Doshi, Ahmedabad, all great architects, these guys. So they designed this building some years ago, 15-20 years ago. But it has got such wonderful natural elements. I will call this a public building because it has auditoriums, it's got many meeting rooms, it has library, it has some offices, anyone can walk in, it has restaurants. So it is very comfortable even in the summer because they have sun breakers, so it never gets too hot. And you can see it doesn't have very big windows, and the windows are all recessed. They don't directly stick out onto the sun. So this is a very good example of a public building. It will be safe. It is something which I want to say that we should look forward to, yet we should feel conscious about it. If you walk through a city on a hot day in May, especially in North India, or even in Chennai and Hyderabad, you will find people, they are moving around on rickshaws, they are carrying load on their head, they are constructing all the buildings which we occupy. Only few of them are protected in air-conditioned homes and offices. The big problem is not just that. The problem is the wet bulb is rising in the world. Wet bulb allows you to remove body heat. If wet bulb is low, you can remove your heat faster. If the wet bulb goes above 30, we will all soon die. And that's what is happening because of the way that the ground is no longer having moisture. So this is, I will leave you with this. The social cost is high if we don't wake up and take care of our public utilities. Thank you very much.